All right, so we're going to continue looking at graphing linear equations, and this time we're very specifically talking about slope-intercept form. So I referenced it on the last video. It's a very convenient format if you can remember that, because it makes it much easier to graph and you don't necessarily have to create a table like what I'm going to show you. So I'll show you both methods just so that you can kind of refresh on that. So when graphing a linear equation, we first build an XY table or function table to organize our coordinates and to show our work. Or, I just didn't put it on the worksheet, we can use the slope-intercept form of a line, which is y equals mx plus b. Okay? So remember, this is our y-intercept, and this is our slope. So this can help me graph the line almost immediately. I don't really have to do very much work here to start graphing. I just have to identify these two pieces. Now if I want to use the table, that's perfectly fine. I just need to choose a few points. So I always go with small points like 0, 1, and 2. And then I can show my work in the middle here. So I have 2 times x minus 6. I'm just going to write these all out so I can switch my pen a little bit less. So I have 2 times 0, because I chose 0 for the first one, minus 6. Well, anything times 0 is 0. Minus 6 is going to be minus 6. So my first point is 0 and negative 6. So I'm not going to go right or left. I'm just going to go down 1, 2, 3, 4, 5, 6. I'm going to place my point. So this is my y-intercept. Do you notice how it's the same? Negative 6 is my y-intercept. So whether I do it on the table or from the equation, my y-intercept will be the same. And the y-intercept is always when x is 0, what is y? All right, so for the next point, I can plug in the 1 here. 2 times 1 is 2. So I'd have 2, oops, not plus, I almost said plus 6, minus 6. So I'd end up with negative 4. So my next coordinate would be 1, negative 4. So I go over 1 and then go down 1, 2, 3, 4. And there's my point. So my last one I chose here was 2. 2 times 2 is 4. Minus 6. So 4 minus 6 is negative 2. So I'd go 1, 2, 1, 2. That. And I can see that's a nice straight line. And I could have also used my slope to do this because I have a 2. And remember, if I don't see the run, because it's rise over run, then it's a 1. So I could go up 2 over 1, up 2 over 1, and I can see that happening. So 1, and I can go backwards, down 2, left 1, down 2, left 1, and give myself a little reference here. Is my system. When you do this on Alex, you're just going to click, and it's going to snap the line for you. Mine doesn't work quite so nicely because it's a little intricate drawing tool here. So this should be pretty good there, and there we go. We have a line snapped. You really don't need 3 points. 3 points is my way to guarantee that it is in fact a straight line, and I didn't do my math wonky anywhere because they all line up nicely. All right, so we're also going to take a look at functions down here and just applying some values to functions. So remember, a function, it's just an equation. It's just a general rule for that equation. It's kind of like a machine or a very specific equation for this situation. So the function of x equals negative 4x plus 2, and the function of g equals 3x squared minus 3x. So we have 2 different equations, 2 different functions, and then they're just asking us to find when the function of x is 5. So they're literally saying when x is 5, what is the function equal? And then g, when x is negative 2, what does this function equal? So we're just going to go ahead and we're going to plug these in. So it's f of 5 equals negative 4 times 5. Instead of x, I'm replacing it with 5. So now I'm just going to go through and solve this. Negative 4 times 5 is negative 20 plus 2. And then negative 20 plus 2, well, that's negative 18, because since it's a negative and a positive, I subtract. The bigger number lets me know what the sign's going to be. Since the bigger number is negative, it's negative 18. So this would be negative 18. And then I'm going to do the same thing for this one. So they want me to plug in negative 2. So it's going to be 3 times negative 2 squared And I'm putting in parentheses because you want to make sure that you're squaring the negative as well as the 2, not just the 2. Minus 3 times negative 2. All right, so we get 3 times negative 2 squared is 4. It's positive because 2 negatives make a positive. Plus negative 3 times negative 2. 2 negatives make positive again, and we get 6. 3 times 4 is 12, plus 6. So I end up with 12 plus 4, and that equals 18. So by chance it was negative 18 and positive 18. That was just a coincidence. You're not going to end up with negatives and positives like that each time. It was just purely a coincidence for the two equations that they decided to put on here, or two functions. All right, so that was graphing in slope-intercept form and dealing with some function notation. So I hope that helped, and I will see you in the next video.